Let's talk about electrolytes and non-electrolytes. These are really quite simple, and we'll look at some of these in class. Electrolytes are substances that conduct electricity when dissolved in water, and you can put in parentheses, or also in the molten state. We typically don't get that hot, but it would also do so then. And non-electrolytes are substances that do not conduct electricity when dissolved in water. So you have probably heard the term electrolyte in regards to like a sports drink, Gatorade, or some of the other drinks. They have electrolytes, and it's true, they do have electrolytes, but that's not really the same way that we look at, and it is kind of, but we're looking at it more from a chemistry perspective. If it can conduct electricity when it's dissolved, then it's an electrolyte. And so what can conduct electricity? What is electricity? Well, electricity, if you know, or maybe you don't know if you've had physics, some of you have, some of you haven't. Electricity is the flow or movement of electrons. So electrons moving is electricity from an area of high electrical potential to an area of low electrical potential is what electricity is. And so that movement of electrons is what electricity is. And so if we can get electrons to move, then we'll have electricity. And so how does an electrolyte versus a non-electrolyte work? Well, salt, for example, is an electrolyte. When you put salt in water, what does it do? Well, we talked about that. It separates into positive and negative components. And so we have these charged components in the water, and water surrounds those charged components, and they're free. Here's the important thing: those charged components are free to move because they are no longer bound together like they were beforehand in the crystal structure. They're not bound and locked in place, but now they're free to move around the water because they've been dissolved. If you put some wires in this water with a battery attached to it, well, the electricity can move through the water because the charged particles will help to carry the electricity through the water. They'll help that electricity move through the water because we have these free-flowing, free-moving charged particles. If you have a non-electrolyte, something that doesn't dissolve, and you run your wires in here and your negative and positive terminals, well, the particles can't move. So the electricity can't really flow through the water to get to the other side because there's nothing to help it move. Now, you might be thinking, but Mr. Brimage, I know that electricity and water are dangerous together. You are correct. They are dangerous together, but not if it's pure water. Pure water has very, very low electrical conductivity. The reason why water and electricity don't mix very well like in your home, because that water in your home is not pure water. The water in the lake is not pure water. The water in the ocean is not pure water. The water in your pool is not pure water. It's very difficult, if not impossible, to find pure water in nature. It's always got stuff dissolved in it, minerals and salts and other things in it. And so what you see in nature is water like this, water that has stuff dissolved in it so that electricity can flow through it quite easily. You will not find pure water or water with a non-soluble solvent only in it in nature. And so that is why you may have this misconception or misunderstanding that water conducts electricity. No, water doesn't conduct electricity. Water that contains dissolved solutes conducts electricity. And so the important thing here about the electrolyte versus non-electrolyte is that electrolytes contain, we're going to use the word ionized solutes. Okay, so this is an ionized solute. It contains ions, positive ions and negative ions, cations and anions. Electrolytes contain these ionized solutes. Example of not an ionized solute. If I put sugar in water, okay, sugar will dissolve, but sugar is not an ionic compound. So when it dissolves, it does not form ions. It simply dissolves as sugar molecules, and sugar molecules are not ionic. I hope that makes sense. We'll talk more about it in class, but the non-ionic nature of a sugar molecule, the fact that sugar is covalent, it's a molecular compound. It doesn't dissolve into these ions that an ionic compound does. And so ionic compounds typically are going to be electrolytes as long as they are soluble. If they don't dissolve, then it's not an electrolyte. So soluble ionic compounds form electrolytes. Non-soluble ionic compounds and covalent compounds will typically form non-electrolytes because these don't dissolve, so we don't get the free-flowing ions, and these don't form ions at all. And so it's that freedom of the ions that makes it an electrolyte or non-electrolyte. Okay, let's talk about solubility and rates of solvation. Now, I need you to make sure that you understand a definition or some comparative definitions, if you will. So the word soluble, the word insoluble, and the word solubility. Make sure that you understand the differences, ability, spell that right, the differences between these three words. Soluble is simply means it can dissolve. It has the ability to dissolve. Insoluble means it cannot dissolve. And these are different from solubility, which is how much can dissolve. How much can dissolve is solubility. It's a measurement. Solubility is like a temperature. It's a measurement of what the kinetic energy is for temperature. For solubility, it's a measurement of how much of the solute dissolves. And so make sure you understand the difference between soluble, insoluble, and solubility. We're talking about solubility now, how much can dissolve. So solubility is a measurement of the maximum amount of solute that can dissolve in a given amount of solvent. Obviously, the more solvent you have, the more water you have, the more you could dissolve in that water. So we usually quantify the amount of solvent, and we usually quantify that as 100 grams. So if we have 100 grams of water, which is 100 milliliters, roughly, give or take a small fraction of amount, depending on the temperature of the water. And so 100 milliliters of water, how much can dissolve? That's what solubility is. You know that you can't add unlimited amount of solute to a solvent and get it to dissolve. So for example, I like to drink sweet tea. I can't just throw as much sugar in there as I want and get it to dissolve. Eventually, it's going to stop dissolving because it's reached its point of saturation. It cannot dissolve anymore. It's impossible. It has reached the solubility point, the maximum solubility point. And so that's what solubility is. If I throw some salt in water, a little cube of salt in water, and all of the salt dissolves, so eventually I don't see it anymore, it goes away, then it's all in the water. It's all dissolved in the water. If I throw some salt in water and some of it dissolves and it leaves me a little cube at the bottom left, but the rest of it goes away, well, why is this salt here not dissolving? It's not dissolving because all of the water is full, if you will, of salt. There's no more free water molecules left to surround it. Remember, the dissolving process is where the water surrounds the salt. There's no more free water molecules effectively to surround any more salt molecules or salt ions, and so this little cube stays behind as a solid. And you see that salt. You can see the little flakes of salt or the little granules of sugar at the bottom of your tea glass or Kool-Aid glass or whatever. And so how much can dissolve is solubility, not if it can dissolve. If it can dissolve is soluble versus insoluble. How much can dissolve is solubility. And then there's the rate of solvation, which is simply how fast something dissolves. So if it can dissolve, we can affect how fast it can dissolve by doing various things to it. And you have some experience with this. Actually, I think we did a lab in the first semester involving this as well.